Hi students, if you've clicked on this video, we're getting ready to talk about something called the constant of proportionality. So go ahead and grab your guided notes and we'll jump right into it. So we're going to start off with this problem. Joe can do 10 multiplication problems in 5 seconds. Okay? The question says, at this rate, how long should it take Joe to do 2 multiplication problems? Well, first off, we want to set up this rate in word form. So we're going to put problems over seconds, because that's what we're looking at here. He can do 10 problems in 5 seconds. And so we're going to come over and write 10 problems in 5 seconds. Okay? The question says, at this rate, how long should it take Joe to do 2 multiplication problems? So we're going to set up the rate. 10 over 5 equals 2 problems over x, because we don't know how long yet. Okay? I want you to go to the side and solve this rate. When you're finished, come back and we'll move on. If you got stuck on how to actually solve this rate, I'm going to solve it very quickly now. We'll go ahead and write 10 over 5 equals 2 over x. Using the crisscross method, we know that we need to multiply 10 times x and equal that to 5 times 2. So I'm going to write that. 5 times 2 equals 10 times x. If I simplify that, 5 times 2 is 10 equals 10x. I know that I need to solve for x and get x alone. So since this is multiplication, I need to do the opposite, which is division. Divide by 10. 10 divided by 10 is going to give me 1. So x equals 1. And that should be our answer. 1 what? Going back to original problem, how long should it take is in seconds. So x equals 1 second. Okay? Now let's go ahead and move to the next portion of this problem. It says to create a table of values showing how long it should take him to do from 1 to 5 multiplication problems based on this above. Okay? Then it says graph the points. So before we get to graphing, we need to fill out this table. Now, the thing to keep in mind, we still have the same rate. We still have problems over seconds. If we look at our table, we can see that seconds is represented by the variable x, and the number of problems is represented by the variable y. So I want you to write this down. Problems over seconds equals y over x. Okay? Now we can set up what we know. We know that Joe can do 10 problems in 5 seconds. So I'm going to say 10 problems over 5 seconds equals y over x. Now I'm going to go over to the side and I'm going to plug in what I know, my x, and I'm going to have to solve for y in order to fill out this table. So I'm going to do the first 2 with you now just to show you how to do this and how you should work these problems out. So on the side of your page, I'm going to go ahead and do a number 1. And I'm going to set up that proportion. 10 problems in 5 seconds equals y over x. Now, for my first row, I see I have x equals 0 seconds. So I'm going to fill it in like this. 10 over 5 equals y over 0. Now I'm going to solve for y using the crisscross method. So 5 times y equals 10 times 0. That's going to give me 5y equals 0. I have to get y by itself, so I'm going to divide both sides by 5. And I end up with 0 over 5, which is the same thing as 0. So now that I have y equals 0, I'm going to come back to my chart. I'm going to write 0 here. Let's do the next one. Okay, same setup. 10 over 5 equals y over x. I'm going to plug in for my x the number 1. Using the crisscross method, I'm going to solve this. So I get 5 times y equals 10 times 1, which gives me 5y equals 10. Divide both sides by 5, and y equals 2. So I'm going to come over, I'm going to write 2. What I want you to do at this time, on this side of your page, you need to solve the remaining number of seconds. So you need to solve for how many problems can be done in 2, 3, 4, and 5 seconds. I need to see all of your work, and when you are finished, come back over, find me, check with me before moving on to the remainder of the notes. Thank you. Go ahead and get to work. Now that you have gone ahead and completely filled in your table with all the y's for this table, you are then going to graph these points on the coordinate plane. For those who need a refresher on the coordinate plane, remember that this side is going to be our y-axis, and this side is going to be our x-axis. Okay? If we look at y, we know that y represents the number of problems. So on the side, I'm going to write number of problems. And my x is talking about the number of seconds. So I'm going to write number of seconds. Okay? Then I'm going to put in my numbers so that I can plot these correctly. So, of course, at the bottom corner is always going to be 0. Number of problems, I'm going to go ahead and number all the way to 10. And for number of seconds, since I know that I have up to 5 seconds, I'm going to number up to 5. Now go ahead and plot your points on the graph and come back when you're finished. So once you have completely finished your graph, you can draw a straight line through it, and you should end up with something that looks like this. Now we're going to move on to C, which asks, what is the unit rate? Remember, when we're talking about unit rate, we're talking about the amount for 1. Okay? We're still talking about the same problem. Joe can do 10 multiplication problems in 5 seconds. So for the unit rate, how many problems can Joe do in 1 second? If you are my smart, bright, intelligent students, as I know you are, you probably have already looked at the graph, looked at the chart, and figured that the unit rate is going to be 2 problems in 1 second. Okay? Now that we have this unit rate, what we can do is see whether or not all of this can be simplified to equal the unit rate. So how do we do that? We're going to set up y over x for each one of these. So that's going to be 0 over 0 here. That's going to be 2 over 1 here, which is already simplified down. That's going to be 4 over 2 here, which can be simplified to 2 over 1, and so on and so forth. Go ahead and do the rest of these and see whether or not they equal 2 over 1. Then come back. Alright, now that you have finished checking to see whether or not the unit rate for all of the responses is 2 over 1, you should see that, yes, all of these can be simplified to 2 over 1. That means that there's consistency within these different rates or ratios. And we can even see that to be true here. For example, since this is y over x, that means we should be able to go up 2 and over 1 to get to the second point. Go up 2 and over 1 to get to the third point. Go up 2 and over 1, up 2 and over 1, up 2 and over 1. This consistency is called the constant of proportionality. So we're going to talk about that right now. The constant of proportionality is in existence when the ratios within a graph table, or ordered pair can be simplified to the same unit rate, just like we did in our example. In order to check and see whether there is a constant of proportionality, you can do several things. For ordered pairs and tables, you can divide y over x for all of the ordered pairs to see if the unit rate is the same for all the pairs, just like what we did in our first example. With a graph, you can create a table of ordered pairs and check by dividing y over x. Okay? So the key thing to check and see if there's a constant of proportionality is basically divide y over x. Okay? So now I want you to flip over to your practice problems. I'm going to start you off on the first one. The first one, we have an ordered pair, and the question tells us to determine if there's a constant of proportionality. First of all, I know within an ordered pair, I'm always going to have x and y, just like this. Okay? So what I'm going to do is I'm actually going to do what the notes just said, and with the ordered pairs, I'm going to divide y over x to see what I get and whether the two will equal. So I'm going to set up y over x. And then for my first one, I'm going to say 9 over 2. 9 divided by 2 is going to give me 4.5 over 1. Okay? So now that I've done my first ordered pair, I'm going to do my second one. Y over x equals 18 over 4. Which also, if I divide that out, is going to equal 4.5 over 1. Now, because these two unit rates are the same, the constant of proportionality does exist. And it is 4.5. So my answer is going to be, it exists, and it's 4.5. Now, I want you to go through and see if you can do the same for the rest of these problems using the notes that we took. And if you need help, just ask a classmate, reference your notes, or come find me. When you're finished, make sure you show me your notes, glue them in your ISN, and then I'll take your name off the task sheet list. Have a good one.